Hello, this is Mr. Leapforth. This is the 2012 free response section of the AP exam. This is question number 1. My assumption is that you have the question right in front of you and that you're probably going to stop and pause this along the way whenever you need to and go back. But anyways, the first question here is that you want to find W prime at 12. So we have a table in this problem that gives you W of t. And so W prime is the derivative, and so we want the derivative at 12, but we're really only given 9 and 15, so those are close points. So basically what you want to do is find the slope between those 2 points. So you got 67.9 minus 61.8, and then you have 15 minus 9. Otherwise, when you simplify that, you get like 1.017 or 1.016, either truncated or rounded to 3 decimal places. That's your answer. So what does that mean in the problem? Because it wants units as well as an explanation. So the water temperature is increasing. We know it's increasing. So increasing, we know it's increasing because it's positive. It's increasing at 1.017 or 1.016 degrees Fahrenheit per minute, because the units for the original problem were degrees Fahrenheit and minutes, and so if you get to a rate W prime, it's degrees Fahrenheit per minute, and this is looking at the particular time 12 minutes. So you would want to write that out in a sentence, but for right now I think we're going to just move on to B. Alright, so for B it asks for the integral from 0 to 20 of W prime of t, which would be equal to W at t evaluated from 0 to 20, and so that would be W at 20 minus W at 0. Alright, so in our problem, W at 20 is 71. That was right in the table, 0.0. And W at 0 is 55.0. And so that's 16. Now it asks you for the meaning. So the water has warmed by 16 degrees Fahrenheit from time 0 to time 20. And so you'd write that out in a sentence, but for right now, I think we'll just go on to C. Okay, so it probably just looks like that graph magically appeared for this, but for C, it wants left-hand Riemann sums, so I would think that you'd want to make a graph. You take the graph and you start on the left-hand most point, and that's your first one. This is not to scale, but on an AP test where I'm timed, I don't necessarily want it to be a perfect graph anyways. And so basically for the left-hand Riemann sums, I'm going to have to find the area of these 4 rectangles. Alright, and not only does it want that, it wants this 1/20th from 0 to 20 of W of t. So I'm looking at an average value problem here. Basically this piece here is going to be calculated by the Riemann sums. And so I have a base here of 4. I wanted to do that in red. So all kinds of crazy things are happening, huh? So the base is 4. The height is 55. So that's one rectangle. Plus from 4 to 9 is 5 times the height there, and that was 57.1. Plus the next rectangle, what is that, 6 times its height, so 6 times the height there is 61.8, plus the last one, that's 5 units times the height of 67.9, and it's left hand, so we did use the left hand, but we didn't use the right hand of the table. So of course you're going to calculate all that and then take 1/20th of it, and the result is 60.79. Now if it's an average value, you would expect it to be somewhere in the range of what we were looking at, and so 60.79 seems to be a reasonable answer. And this particular case, if you look at the graph, it's an underestimate, and it's an underestimate because the graph is increasing, and so that would be your justification for that. Alright, so that's part C, and then for part D, probably have to bust out our calculator for this one, but For D, it says for 0 to 25, we want here it is, based on the model, what's the temperature at time 25? So we want W at 25. Oops, I said 25 but wrote 20. So W at 25. So we know that at 20, it was 71. We got that from the table. And we want to add to that what happens between 20 and 25 for W prime and T. Now, and that's dt. And actually, it gave us this strange function for W prime at T, and it was 0.4 root T. You got the cosine of 0.06 T. Can I squeeze it in? Yeah. And so we're going to get out our calculator. It takes a sec to come up, and we're going to turn it on. And it looks like I got some stuff from before, so we can clear all that out. Probably want to make sure I'm in radian mode. Okay, good. So we have this, and we got 0.4 square root of T. And so, of course, some of the problems on the exam you actually have to use your calculator for. You don't have a choice. Don't use T, use X. Your calculator won't understand T. And it looks like I typed that in correctly. Not incorrectly, but incorrectly. Math 9 is how we do it on the TI. So function integrate, you use the function that you have. And so I went to variables for that, over to y variables, and basically hit enter twice. Okay. And my calculator wants to have a little bit of fun with me as long as I'm being recorded. So x, you want to integrate with respect to x. We want to start at 20 and end at 25, and it's going to give me an answer here. I got 2.043, etc. We want to keep that in there. Add the 71 to that, and then it's going to be 73.043. That's 73.043, 3 decimal places. Truncated or rounded, and you want to make sure that you have the integral. You got points for having the integral here as well as the answer. And this particular one didn't ask for units or anything like that, so you're done with question 1. Nice job.